All right, so we've got a vapor compression heat pump cycle. We know all the enthalpy values and we know the M dot. And we're supposed to find the heating capacity, which is the rate at which we're adding heat to a heated space, and the coefficient of performance. I'm going to need to make the assumptions that this thing is operating at steady state and kinetic and potential energy changes are negligible, and that way when I apply my conservation of energy to each of those components, to the compressors, to the compressor, the evaporator, the condenser, and the throttling device, I'll only have things in terms of delta H's. So the first thing I need to do is kind of orient myself as to what's going on in this cycle. So as my refrigerant flows from 1 to 2 down there at the bottom through the compressor, your pressure is going to go up and your temperature is going to go up. So coming out at state 2, your temperature should be pretty high. And if the temperature of your refrigerant is higher than the temperature of your heated space, then heat is going to always flow from what's hotter to what's colder. So your refrigerant is hotter, your heated space is a little bit cooler, and so your heat is going to flow out. So that's your Q dot H or your Q dot out if you want to put it that way. So as it moves from 2 to 3, that refrigerant is going to condense. It's going to come out at state 3 as a saturated liquid. Then you're going to throttle it down to an even lower pressure and a lower temperature, so that if the temperature at state 4, if the temperature of your refrigerant as it's flowing through that heat exchanger from 4 to 1, which happens to be your evaporator, if the temperature of your refrigerant is lower than the temperature of your refrigerated space, heat is always going to flow from what's hotter to what's colder. So at this point, what's really hotter is your refrigerated space, and so heat is going to flow from the refrigerated space to your refrigerant, and that's your Q dot L or your Q dot N to the cycle. So at this point, I'm ready to solve for what part A is. So Q dot H is between 2 and 3, so it's M dot times H2 minus H3. And now I need to figure out what my coefficient of performance for the heat pump is. So it's what you're interested in over what you have to put into it. So it's Q dot H over what W dot net in, and I know that W dot net in is W dot in minus any W dot out, and the only thing I really have is W dot in, and that W dot in occurs between 2 and 1, or 1 and 2, so that's my compressor. And so if I plug in the numbers, my W dot in is M dot times H2 minus H1, and then my Q dot H I've already solved for. So, all right, well, I hope that makes things clear. Thank you for watching.